Triangle ABC has vertices at A, -5, 2, B, -4, 7, and C, -2, 7. And triangle DEF has vertices at D, 3, 2, E, 2, 7, and F, 0, 7. Graph and label triangle ABC and triangle DEF on the set of axes below. Determine and state the single transformation where triangle DEF is the image of triangle ABC. Use your transformation to explain why triangle ABC is congruent to triangle DEF. So looking at this, I already have the two triangles drawn. I'm just going to relabel that. So looking at this right now, one thing I notice about these two triangles is ABC is drawn in a clockwise orientation, whereas DEF is drawn in a counterclockwise orientation. And this is not dictated by, I didn't have any influence over that. It is just what the, how the problem here is stated, okay? Because ultimately at the end we're trying to prove that these two are going to be congruent. And in doing so, A corresponds with D, B corresponds with E, and C corresponds with F. So again, ABC is clockwise, whereas DEF is counterclockwise. So in order for that to happen, there has to be a line of reflection, because reflections is the only transformation, is the only rigid motion that will cause the orientation to be reversed. So what we're going to have to do is we're going to have to perform a reflection over the line x is equal to -1 of triangle ABC. And this will map onto triangle DEF. Now, to answer the other question here, it says, because I've determined the single transformation that will, where DEF is the image of triangle ABC, the second part of this says, use your transformation to explain why triangle ABC is congruent to triangle DEF. Well, this has to equal to triangle DEF, and triangle ABC is congruent to triangle DEF because this is a rigid motion. So all rigid motions preserve distance and angles. Therefore, the two triangles must be congruent. The image and the original must be congruent. This is the very nature of what it means to perform a rigid motion.